So yeah, it was planned that we were 4 people, but I'm alone, so I will start alone, and then invite other people. So in Rakuten Group, we deal with a lot of image data, and we have many use cases for computer vision application, and a lot of expertise also in this domain. In less than 10 years, as you probably know, with the development of deep learning, computer vision application make tremendous progresses, and in many domains they outperform humans. And so in Rakuten Institute of Technology, of course, we use a lot of deep learning, and more generally we leverage the results of academic research and industrial research. And also we contribute to the research community by publishing papers about the work we do. And I'm very glad to introduce 3 great researchers from Rakuten Institute of Technology. So first, Pablo Montalvo. So Pablo used to be a researcher in physics, and now he works on video and image analysis. And he will talk about action recognition and evaluation of aesthetic values in video content. And Bjorn Stenger. So Bjorn is a research group manager in Rakuten Institute of Technology in Tokyo. He has 20 years of experience in computer vision, and he will talk about computer vision and creativity. And Madan Dabbeeru. Madan is the head of RIT Bengaluru. He's an expert in robotics and cognitive science and medical image analysis, which is the topic he will talk about. So we will start first with the presentation by Pablo.
Yes, so thanks, Laurent. Hi, everyone. So I'm going to talk about video processing applications and what we do with video data here at Rakuten Institute of Technology. So why video? Video is a type of data, type of format that we have every day on our smartphones, on our TVs, and it's unstructured type of data which contains a lot of informations. And you've seen today a great number of talks about 5G and the future of bandwidth and data that will be in the future available for users. So it means more streaming, more video data, and more content that we can ultimately use and leverage using machine learning, AI. So I'm going to talk about an overview of some projects we have and some services we're able to deploy, and to zoom in on a few applications. So let's see the problem from afar. If you have a very famous busy crossing over there, it contains lots of stuff is happening there, and you want to get structured data from that because you want to be able to tag the video and determine what is going on, to be able to research in the database where this video, where did this video occur, what happens on it, who is in this video, what this person is doing. And this kind of thing is, of course, not available when you put your hands on the video. So, for example, here you have people walking, people driving cars, people maybe pushing each other, these kind of human actions. You have many objects that are here. You can overall try to caption in a more general way this video with, okay, for example, there's a lot of people, there's a crowd, there's a city. These actions you have to obtain through machine learning. So I'm going to go quickly over this slide, but what you can get from a developer perspective is you upload your video and it's processed and you get this structured data as an output. So the objects that are in there, the people, there's no famous people recognized there, the actions, the tags, and a selection of posters that are deemed to be the most aesthetically pleasing. That's one of the modules we developed. I'm talk about it later. So this is how it works. Every type of AI application is through a specific service. So one is dedicated to object detection. One, so detect where are some specific things and what are those things. One is scene change detection, which it means globally how the video is changing from a higher perspective. Action recognition, what is happening, what are people doing in there, and also an aesthetics module which determines which are the best frames in this video, what is the best content that we can use for maybe social media curation and this type of applications. So for the first one, smart splitting, you have a global video. The first thing you want to do is cut this video into meaningful segments. That's what DVDs do. There's chapters that are really well defined semantically, manually. Okay, this happens here, then this, then this. What you do for that, you use deep learning to determine statistics about frames and successive frames, and you look when the statistics change globally, so that you don't cut through a conversation. You have a conversation, then cars running. And this type of thing, if you do it there, you will have first cars crossing, ship crossing, and then people walking. You don't know more about that, but this will be two separated things on a non-supervised way. The second thing is object and people detection. I'm sure you've heard of these very famous applications. It's one of the most efficient thing that goes on in computer vision that uses deep learning. And so this here you can see that you identify cars and people, and this is on a video, which may be useful downstream for any application that will need to identify what's going on in the street, for example. So this is this segment, and so this one is a very challenging one research-wise. It's human action recognition. It's very difficult, and it's very difficult to focus on humans. But there's been some very strong research going on with i3D and other type of applications recently, and it's still experimental, but it's possible to use it in a pre-labeling way. And for example, here you will find out if you run that you have marching, so you have people actually marching and driving cars. And if you run it, where you run this kind of application on a drama where people are running, you can see running, and this type of basic actions, and also more complicated actions, such driving car is not a very basic human action, can be determined automatically from that. Okay, and the last one, which is the aesthetics module. So this is very important if you want to. It's also very how to say controversial. It's how do you determine which frame, which moment of the video a user will like the most, which is the most appealing to the eye, to the human eye. So to do that, we used, so Google worked on that a few years back, and we developed our own technology from that. And we used a photography contest where users ranked pictures, and we teach an AI to imitate this kind of ranking. Okay, this picture was found to be good by many users, so it must be good. So if you run that on a video, what you obtain is a selection of frames that will be ranked according to the appealingness, to the aestheticness as predicted by the AI system you have, which can be used downstream to create social media content automatically. You have a video, bam, you create all the best images, and you can have a preview that will be automatically generated for each image. Okay, so that's it for my segment. Thanks.
Thank you, Pablo. So we will have a session of questions after the two presentations, as Rich said. So now the turn of Bjorn.
Yes, so I will follow up from the aesthetics that Pablo introduced. So I will talk about creative AI. Creative AI, and I tell a bit more what I mean by this. So let me first start by showing you the first webpage of Rakuten. Maybe you've seen it downstairs in the museum. So Rakuten was started in 1997, and you can see it started with only a few merchants, and it was, that was the style of the web pages you had at the time. And this is 22 years later. This was in June of this year. So you can immediately see there's a lot more visual content, lots of different images, banners, and call for actions with all these different fonts. And so there's a lot of work that goes into creating all of those, right? So when you talk about computer vision, often what we mean is perception, and I've worked in this area, looking at people, looking at faces, understanding what's going on. But now in the last 5 years, there's also been this trend of, how can we perceive but also create? So when you think about intelligence, it's not just about perceiving the world, but also being able to create. That is like, what we perceive as, for example, an artistic, as, some way of intelligent. So that's what a graphic designer is doing. So they are taking the content, for example, given from the ad agency or from the content provider, and they have to create a particular banner, for example, right? So then the question is, can we help them? Can AI help them in some way to automate this process or to help them be more efficient? So AI can create. I put create here in quotation marks because, what do you mean by create? Well, one example is AI can create images. So maybe you've heard of GANs, Generative Adversarial Networks, which are now 5 years old. The ideas go back further, but essentially what it means is you have networks that cannot just recognize things in images, but that you have networks that generate images. So you input something and you output an image. So in this case, you input a single image. This is a result from a prize-winning paper of this year's International Computer Vision Conference. So you input, for example, the top row here, you input the image on the left, and then you can generate lots of variations of that image, right? So these kind of tools will become much more common in the future and open up, totally new possibilities for artistic creation. AI can generate faces. Some of you may have seen those kind of examples. I think they are super impressive. Generating faces, there's this website called This Person Does Not Exist. And if you look at those people, they are generated, again, by similar methods. And they are not real people, but generated from a training set. In this case, not just one image, but lots and lots of images. But they learned the features of images, the different hairstyles, glasses, and all those kind of things. So you can imagine how complicated it is that, in an image you just have pixel next to pixel, but they have to have some context. They have to know, for example, if there's a pixel belonging to glasses, there's a whole glass that goes here and here. You can also create anime characters, which may seem easier, but anime fans will know that it has to look cute, and cuteness has to be generated by the neural network. But it's not just images. So AI can generate stories, and there's a website where some of the latest research is demonstrated, where you just type the first sentence and it can generate a full paragraph. You can generate whole stories like this, and if you read them, they sound pretty plausible. So it's getting better and better. So here I wrote, I attended the Rakuten Tech Conference 2019, and let me see, the OWC 2019 in Japan and Korea. That was there. I got some great insights to share my teammates, and think this post is a great example of that. So it goes on, and every time you enter something new, it enters a new text.
It's really addictive. I tried that. Both the one generating faces, this person does not exist, and this one, you can spend hours to.
Yeah. So, and finally, also music. There's an interesting website where you, for example, input Mozart, and then you ask for the style of Chopin, and it starts with Mozart, a theme, and then it continues to improvise in Chopin style. So this is kind of what's going on in the research field, and I will now talk a bit more, what is necessary for creative AI. So what do we mean by creativity? So I say 3 tasks are important. So one is, let's imagine you go to a museum, right? So there's already lots of art that is there, and you want to kind of rate it, so how you like it, how you don't like it, right? So that's something, imagine you are an art critic. So that is something we can do, everybody does kind of automatically. Can we teach that, right? The second one is enhance. So if you say, okay, you like it, or let's say you don't like it, so is there a way you can improve an image, for example, or a song or whatever, right? So that is another key element that you want to have. And then also create from scratch, basically. And now I will show you examples within Rakuten where each of those are addressed. So rating images. So one example is the so-called Clean Image project, where the goal is to make the visual appearance of the images on the website more appealing, cleaner, And you can see some examples. And here the rating is relatively straightforward. It's based on rules. So you have certain rules, such as there shouldn't be a border. There shouldn't be too much clutter, like a background. There shouldn't be too much text, and so on, right? So this is one example based on rules. There is also rating by perception. So you can see here are two examples of baths in hotels, and you can see that clearly the left one is more appealing if you want to book a hotel than the right one. And can we learn this? Yes, we can learn a model similar to what Pablo described based on statistics of users or even feedback from the website. So that's rating. Can we enhance images? So yes, we have methods for learning a transformation from one input image that is maybe not enough contrast or not sharp enough to an improved version. So we can automatically tweak the parameters of images. We can create super resolved images. So imagine we only get like a very poor quality JPEG compressed image, but we can upsample it. And this is kind of the principle behind these methods. So you have an image, you can downsample it various ways, and then from those pairs of images you can generate, you can learn the transformation that then generates a high quality image. So here are some examples of enhanced images. The previous one on the left, and you can see the right version is sharper here. So the croissant looks much more edible on the right. And finally, creation. I would just give you the example of how to create banners. And this is one example of, for example, if you can generate banners, you can personalize banners to particular cases. So in this case, a user searches for a backpack, and then you can create a banner that has an image of a backpack. And you can, for example, adjust the color of the banner depending on the image. So you have product images, you have certain rules based on the color of the image, and then you create a suitable template that makes it, in this case, for example, tangerines created with a green banner is much more appealing. And here are examples of different color schemes that we tried. For example, complementary colors is one way, or harmonic, monochromatic colors is a different way. So, and these were some of my personal favorites. So these are then basically fully generated. And to make it more general, you can just input all the different components from banner layout, background, foreground, logos, shapes, fonts, and text, and then ask the system to create lots of variations. So the creative task has been basically moved to a way to combine all these elements in a smart way, but then also to rate, is that what I created good or not? So maybe similar to an artist that does first a sketch and then later picks the best ones and then does those properly. So AI can create hundreds, thousands, millions of different variations, but then you also need AI to be able to rank and say, okay, this is possibly a good one and this is not so good. Yes, and this is where I stop.
Thank you very much. So yeah, creating attractive picture is very important for the user experience and for the business, especially for Rakuten. But we even do more important stuff. We work on medical images, as I will explain, Madan.
Yeah. Thank you. I cannot see either this side or that side, so better I stand. So this topic is a bit very different from what Bjorn and Pablo had covered. So I just want to ask you a few questions before I start here. To understand my body, whatever is happening, there were no techniques other than just dipping through my body through a needle, which we call surgery. So many people had started in 1895 how to solve this problem. They came up with the different technologies, like X-rays is the first technology, right? And then in 1970s, people had come up with another technology, that is magnetic resonance technique. So using all these techniques, people are trying to understand what is happening in my body to really cure whatever the disease that I'm having. Now, if I'm getting a headache, I go to doctor and I will say that, hey, I'm having these symptoms. So he would give that medicine. This is what the current state. In the future, the way we are expecting to take the world is where I would go and ask, hey, give me my medicine, which is more personalized to my headache. So how do we achieve this? It's not that easy to develop a medicine which will really be more personalized towards you. So this is the effort that we are actually trying to see in the future. How can we take the help of all these advanced technologies so that to help the mankind. So how do we build a different tools that can support and take the decision that I can develop the drugs that can help you more in the personalized way? So in order to achieve this one, okay, I would take an example of a cancer. My aunt died with a cancer 8 months ago. And this is the one number I can say. If I talk to 1 in 100, at least one of them would say that yes, his maternal uncle or somebody has died of cancer. There is no cure, there is no technique that really helps them. Yes, we are able to identify cancer. But how do we really cure that one? People try different techniques. One of the techniques is chemotherapy, which is not only going to kill your cancer cells, but other organs as well. Is this a really good technique? Many physicians, many doctors, many researchers are actually putting their efforts to identify that how do we really identify the cancer. So one of the ways that we can really understand any drug that is whether it's working for me or not by getting lots of data about me. Just take an example of e-commerce. In e-commerce, based on your clicks and based on your purchases, I can at least understand that what exactly your interest and what is your life status. Whether you're married, whether you're renting a car, or whether you're really having your own house. Similarly, based on the understanding of my particular body's different organs, how they function, should I be able to build a medicine that can cure him? So in that particular stage, if I want to really understand what are the different types of data that I can get out of my body? Yes, let us say I go to the doctor and say that, hey, I'm having these kinds of symptoms. He would say that, hey, you have to go through X-ray and all these different things. He wants to understand what is happening in my body. So if he wants to build a kind of a personalized medicine for me, he has to really go through thousands of different images, whether it can be X-rays, whether it can be he's taking my biopsy and going through different types of chemical processes to understand that how my cell structure is working. So all these things where I'm getting a 50 GB or 100 GBs of images data, he is actually going to have. A pathologist who is actually going through my analysis and coming back and telling that, hey, he is having a cancer. The probability of cancer is this much. To tell that they're at least taking almost like 4 to 6 weeks. But can we make it happen with these computer vision technologies is what we are actually focusing at RIT right now. We also are collecting gene expression data, blood analysis data. So we are trying to automate and build the tools which can really help the pathologists or the doctors to take the decision. It is not that we are trying to replace them. So the main objective here is that how can I better help the doctors to take the decisions with our AI tools is our main objective here. As I mentioned, a personalized medicine if I want to build a medicine for each person based on his cell structure, based on his response to that particular medicine. And similarly, in order to achieve that, a pathology flow, which they are taking my biopsy, going through different microscope studies, and then they are actually coming back and telling that your cancer is at stage 3. Why can't I know that before the stage 1 itself? Will it be possible? Can I reduce the time? So for this image analysis, the first problem that we are actually trying to focus and trying to solve here is that cell counts. How do I identify the number of cancer cells those are actually there in my body? And how do I really identify the cells those are actually going to fight against this cancer? And what is their spatial distribution? What is their cell size? What is the main property of any cancer cell? The mutation happens randomly. It is not structured way, right? So how do I understand why it is happening? So in order to understand that, if I have given a medicine to him, how this particular cell structure is changing, what is that analysis that I have to do so that I can stop that a particular cell and going and fighting against the cancer cell? How do I find out? So in order to find out that lots of images, we are getting nuclear segmentation and label map prediction. And also not only that, cell study we are doing, and also we are trying to identify brain tumor. It's very easy to say that, hey, this particular portion of the person you are having a brain tumor. but it's very difficult to find out in the very early stages that particular very small portion. It's very difficult to segment it by a pathologist, but it is possible by using all these computer vision technologies, and we have found that. Just to quickly go through all these things. So that is the image, left-hand side is the image that I'm having, using some UNets. Okay, it's one form of convolution neural networks. Using that, we are able to identify a very good segmented nuclei. A pathologist who is actually looking at the left-hand-most image, how much time should he take to count all the cells? Yeah, a simple image processing technique would be helpful. But to get a good accuracy, what are the best ways that I can do? And using some other techniques, the rightmost bottom image, that is actually giving me the clear set of number of cells that I can identify. Similarly, this is the technique we are using. And now, can you look at the left images? Can you get any image? A human, I can really understand how many number of cells are there? No. It's very difficult. Whereas, using all these techniques that I mentioned, I should be able to identify the better segmentation of these cells, and I can easily say that how this particular cell is behaving. Quickly, at the interest of the time. So we are developing different techniques to identify these number of cells and how they are interacting. So this is one of the examples of the brain tumor from the MRI images we are able to find. If you look at the right bottom one here, that particular, it's very difficult for any pathologist to identify the stage of the cancer. Last but not least, once after identifying that, we are using machine learning algorithms to identify, just like how the age is correlated to the weight, we want to identify how this cancer cell is correlated with this T cell. So we are trying to identify how the cells are actually going to fight against each other. So this is the different distributions. Those are all actually telling that after giving a medicine, how these cells are actually acting, that actually gives whether he is completely recovering or not. So this gives a kind of indication to the physicians to say that what kind of drug should I really assay. If I look at this one, final, this is the one. If you look at the leftmost one, there are some blue, green, red cells. So it actually gives that surrounding this particular tumor cell, how many good cells are there? Then I should be able to say that with a probability that, yes, this person may likely to survive. May not be for more, but at least more than 3 years. So I can estimate that how much time he can really live based on the cells, spatial distribution, how they are varying. Thank you so much, and we'll go to the next one.
Thank you, Madan. Thank you to the three of you. So maybe at that point, some people have questions. I can start by one, or okay.
Yeah, so you said that in the aesthetics module, you kind of labeled the dataset which is good or bad from some photographic contest. So, yeah, so my question is, how many people actually participated in them, and how can you make that model like general model or universal model, because it is, this type of things is subjective, right? So it will vary from people to people, region to region, time to time. So how can you make it universal?
Yeah, good question. Yeah, of course, aesthetical perception is subjective, and I mean, for the dataset I mentioned, it's hard to say how many people you need for it to be statistically significant, right? Because you don't know how many people you need to cover perception. But what you can find out when you look inside the data of how people perceive things is that, okay, maybe people will rate things differently, but 3 behaviors emerged. Most pictures, most images, if you take all humans, globally we find it average, which makes sense. People have different tastes, right? But there is some agreement, whether it's really terrible or really a great picture. If you look at the average moments, if you look at the average as a moment of this distribution, I mean, in the very noisy distribution, then you can figure out these 3 behaviors. So that's where you should look if you want to build a more general aesthetical dataset from this approach, but there are other approaches. Yes.
Are there any other questions? Please raise your hand.
Hello. Hello. Actually, I want to know if getting medical data is very easy, or is Rakuten working with the hospital or doctors, or because there are some issues with medical data, its confidentiality, and also bringing such technology to the market is also very challenging. So I want to know. And also, second thing is something common. And regarding image data, do you just look at the images, or do you use the metadata, something like scale or the pixel ratio, or something apart from the images for your model? So
Yeah, first question I'll take, second question I'll give it to Bjorn. So coming to medical data, yeah, you're right. It's very difficult to get the data. Reason is that in order to get a simple set of biopsy from a patient, which is really painful for any patient. So in any process which is involved where I want to take their blood sample and doing all these things, I need to take their consent and everything. This is the biggest challenge because I might use the data for another purpose, right? So I have to maintain their privacy. This is one of the biggest challenges that we have. And also second one here is that whenever we get this particular data, the main challenge is that one particular person to the other person, there is no similarity that you can find if you want to use any kind of better techniques. So the data is very less, and still we are trying to get more data. Yeah, that's very true. That data is very less, and there are some techniques we are actually using to improve that. Yeah.
And in your question, there was maybe something related to the you mentioned metadata, so maybe the particular type of equipment. So for instance, there were some mistakes done in automatic analysis because of a change in the equipment and the quality or characteristics of the images. So that's a tricky question.
Yeah, we cannot take risk. We cannot take risk with patients, right? We have to be very, very accurate in that. Yes, we use that data.
So just to follow up, maybe you're asking about hospitals, right? So Rakuten Medical, who you are collaborating with. I'm not sure if you mentioned it, but I think that's the easy answer, right?
So Rakuten Medical is earlier called Rakuten Aspirin. Okay, many of you may have gone through Kitagawa-san's presentation this morning. So Rakuten Medical is actually developing a technique called photoimmunotherapy. That complete Rakuten Medical is based out in San Diego, USA. So with the consent of the patients, they are conducting some trials. Right now we are in the clinical phase trial 3, and there we are getting lots of patient data as well. Yeah.
And to follow up on the metadata, so of course we are using images as computer vision researchers, but there's a whole lot of people looking at language and natural language processing, and we're combining information sources to get much more accurate results as well.
Thank you. I believe we have another question.
Yeah. Also about medicine, you said we want to help doctors and not replace them. So, like, why not replace them? You may be hinting that there's some problem with like interpretation of the model's predictions or some other problems. What do you think are the big problems in, having the machine completely predict what is the prognosis for the patient?
One question is that, before answering your question, we are developing the AI technologies not to replace the humans. We are building the technologies that can help and support. For example, if why am I having a car? Because I cannot walk for hundreds of miles, right? So similarly, it's not that it is completely replacing a physician or doctor. So at least a patient, when he comes to me, earlier it takes at least 8 weeks for me to understand his cell structure. Now, using all these statistical analysis and machine learning methods, I would be able to see that which cell is the most important one that is dominating his thing. looking at that, I'm not stopping him to curing the cancer completely. No, I'm not saying that. At least I'm identifying that what are the cells I should be able to assay and should be able to introduce that, so that these immune cells get more activated and fight against the cancer, so that he can at least stay instead of 5 years, maybe 8 years. So that is the current state of the art. But yeah, to answer your question, we are actually building the tools to help the physicians and doctors so that they can take the better decision.
Yeah, this is also related to the limits of what AI can do. This is a very important question. And we all know, or some of us know, that there are very strong limitations in even if in the most powerful deep learning algorithms. You probably heard about adversarial attacks. We try to make a model make mistakes, and it can have impact for autonomous driving, for instance. And also, we know that in AI, we currently are totally not able to have any type of common sense reasoning. So a doctor usually has some common sense that he uses or something he takes from his experience we're not able to reproduce with AI. So I think that's one reason why we don't plan to replace doctors.
Hello everyone. Okay, my question is towards Mr. Madan. So your topic is quite interesting among the lot, I guess. So I have two questions. The first one is, are there any sort of ethical aspects and how you're addressing when you say personalized medical assistance? And the second would be, if Rakuten is developing some sort of technology in this domain, I'm sure you're aware of IBM Watson, and they have been already deployed today.
Yes,
and
yes.
a few of the hospitals, example, you're from India, so
Yes.
Manipal Hospital and IBM are in a partnership in
Right.
this domain. So how do you consider yourself to be different from your competitions? I just want to know.
To answer your first question, ethically, first, we respect the privacy of the person. And before we actually go and start doing analysis or collecting any data, first we would ask the question that whether you are interested or not. This is as part of any process that we actually conduct any kind of analysis data. For example, the same example, Manipal Center, which would not give the data just like that, any person. So there are a lot of data governance methods that we have to really follow, regulations and everything. So we do respect the patients first and their consent. And now coming to the second one, if I look at this one, IBM Watson, okay, yes, it is a system that is able to help the doctors to answer some questions. It is not directly replacing the doctors there. Okay, so there, the way IBM Watson had been built, which is actually taking thousands of millions of records of the previous prescription data, and will be able to these young doctors to really help them. Hey, if he is having a neck pain, there may be chances. It is giving with the confidence. This is the confidence. I would say that this may be the symptom, this may be the reason. It gives the confidence. Our direction is not in that IBM Watson direction. Our direction is that how do we really automate the pathology flow, for example. This is the first problem we are trying to solve in this particular domain. Of course, we are having many technologies or vision in terms of building how do we detect the cancer in the early stage itself. That is in the second phase that we are not focusing. But the first thing, if I want to compare that one, ours is completely different from Watson, number one. Number two is that we are trying to automate the processes by using these imaging techniques is our first and main objective at this point of time.
I think we have time for one more very quick question.
Hello. Also towards you. I have a more general question. So I think one of the reasons why diseases got detected pretty late is that not everybody is doing regular checkups. So my question is, does Rakuten have any plans to get those kind of data even before the patients get to the hospital? For example, through AI-based mirrors or smart fabrics or some kind of these technologies.
So your question is that whether Rakuten is planning to get any data other than what the current data that it is actually, for example, they're actually doing.
Yeah.
Yes, definitely. So that the way I mentioned there, it's not only that image data we are actually taking, we are also taking the genes data, genes expression data, so that I should be able to query thousands of genes expressions to say that what is the stage of and how these mutations are happening here. And I also take the blood marker data. So I'm actually not focusing on one type of image data, but also the other data. But your question is something like the regular checkups of the data. Yes, it's a very good point. Thank you for suggestion. If we can collect such kind of data, that would be really, more helpful. Always data is power, Thank you.
Okay, thank you. And unfortunately, that's all we have time for today. So please give all of our panelists a big round of applause. Thank you.